We now want to look at solving some right angle triangle problems. Hopefully you're looking at this going, yeah, I'm pretty confident with this. If not, then that's okay. Hopefully you'll be confident with it really soon. So hopefully you've got your own way of going through this. If not, have a look at the way we do this. What we've got to do when we solve problems with trying to find the angle or the sides of a right angle triangle is identify what ratio we're using. We know we've got three we can use: cosine, sine, and tangent. And it really just depends on what sides we're given in the problem. And that's really what we've got to concentrate on. So in this case, we've got a problem where we've got an angle of 38 degrees. Now we're given the hypotenuse of 16, so that's why we've marked in the hypotenuse. You don't always have to do this, but it helps if you can look at a triangle. I've put it explicitly. If you do it implicitly, that's okay. But we're looking at our triangle and going, well, that's the hypotenuse. This is the adjacent side. That's the opposite side to 38 degrees. Now it's all about the 38 degrees. So in this case, the two sides we've got are the adjacent and the hypotenuse. Because we're doing that, we're going to use the cosine ratio. Remember, we're going back to SOHCAHTOA every time. So if you're not sure, keep writing that till you are remembering it. So we're using the cosine, which is uses the adjacent and the hypotenuse ratios. So we can set up an equation. Our adjacent side over our hypotenuse is equal to cosine of 38 degrees, which means we get x over 16 when we do our substitution. So we replace our values, substitute the x and 16, and then solve our equation. We need to get rid of 16, so what number divided by 16 equals cosine of 38? And that would be 16 times cosine of 38, which gives us 12.61. Now have a look there and make sure that we've done it correctly. Does 12.61 sound reasonable? It does, because it should be less than 16. If we do our calculation and get something more than 16, we should start thinking we have a problem, because hypotenuse is 16 and nothing should be greater than the hypotenuse. In this one, we've got the opposite side and we've got the adjacent side to 16 degrees, so that's why we're going to use the tan ratio. So we set up the opposite on the adjacent equals tan 16, so do our replacement, multiply through by the 5, gives us 1.143. Now that sounds reasonable as well. Remember, in any triangle, the smallest side is opposite the smallest angle, and vice versa. The largest side should be the hypotenuse, because that's opposite the right angle, and neither of these two angles should be greater than 90. So 16 degrees should be much smaller than that, because the two add up to 90 degrees. So 5 is opposite the middle angle, and x is opposite the smallest angle, so it should be smaller than the 5. And that sounds reasonable. Again, keep checking for the reasonableness of your answers, just in case something goes wrong on the calculator. You hit the decimal in the wrong spot, or you leave out a digit. So don't always trust your calculator in that respect. This time we've got the adjacent side and the hypotenuse. So the adjacent and the hypotenuse is equal to cosine of 48. So x on 11 gives us the cos of 48, or x is equal to 11 cos 48. Same thing with this one. We're going to use the sine ratio because we've got the opposite side over the hypotenuse. They're the two sides we've got. We're setting up our equation with one unknown, and we're able to solve. And that's what it starts to come down to, being able to put in an equation with one unknown. This time, a little bit different in that we've got the adjacent and the hypotenuse with the 38 degrees. So we've got a cos ratio happening, and that's going to give us the 10 over the x. Now notice the x there is in the denominator, not where we had it before. So this time, basically, we multiply through by x and then divide by cos of 38 to give us this equation. The effect is that these two just swap around. So you can do that in one line. But realize that's what we're doing. Multiplying by x, dividing by cos of 38 to get x by itself. And again, put that in your calculation. Check for its reasonableness. Whatever the answer we get here should be greater than 10. So that 12.69, that sounds reasonable, because it should be greater than 10. In this one, we've got the sine ratio, because it's the opposite side with 16, the hypotenuse of x. So we substitute that in, sine of 41, manipulate our equation to get x by itself, and 16 divided by sine of 41, 24.9, which sounds 0.39 sounds reasonable. See here we have the tan ratio because we've got the opposite side and the adjacent side, so nothing in the hypotenuse. So again, 15 over x equals tan of 67, or 15 is equal to x times tan of 67. So x is 15 on tan 67, which gives us that answer. Again, that sounds reasonable because 15 is opposite 67, which will be greater than the other angle, which the adjacent side's opposite. This time we got the cosine ratio because we got the adjacent side and the hypotenuse. Again, we do our calculations as we've done before to get x by itself, and then do our calculation for x. In these ones, this time we've got to do a little bit more. So we want to find sine theta cosec theta second cot given the angle here. Now, if we got this situation, we know that the cosine of this angle would be 7 on 12 because it's the adjacent side on 12. What we don't know, and what we need is we need sine of theta, which we need the opposite side. Now we get our missing side as root 59, not square root of 95 by Pythagoras' theorem. So the square root 12 squared minus the 7 squared, and then take the square root, and it will give us our missing side, and that's where we get the square root of 95 from. We're leaving it like that because we want the exact value. Now we're going to do a lot more with exact values in trig, which means we don't want decimal approximations. We need to leave our sides in that correct square root there. We can't bring that down, it doesn't simplify down. So what we're left with is just the square root of 95, because that was root 95, over the hypotenuse, which is 12. Cosecant's 1 on sine, so we take our reciprocal. Remember, we told them reciprocal ratios, so it's 12 on root 95. Secant is 12 on 7, because that's the same as 1 over cosine. As we just said before, cosine was 7 over 12, so this becomes 12 over 7. Cotangent is the same as 1 over 10, and 10 is the opposite on the adjacent, so we get the adjacent on the opposite and get the 7 on root 95. So there's how we can find that one. Finding P in this case, we've got 43 degrees 51 minutes as our angle. So again, we can use degrees and minutes. We've just concentrated on degrees before, but that's okay. Again, you should be able to put that in your calculator. And so set up that as the adjacent side over the hypotenuse. So we've used the cosine ratio. Multiplied through by 8 to get 5.8 as our answer. Finding x there, when it's the hypotenuse, we have 49 degrees 19 minutes. Opposite on the adjacent, on the hypotenuse gives us sine ratio. So we're able to put that into our calculator and solve to get 9.2. This time we're finding the angle itself. Now, again, you've done one with the angle. We haven't done any in this video at this moment. But again, if this is our angle, we've got to find the two sides that are where we want to relate. So we've got opposite side and we've got the adjacent, which means we're going to have the tan ratio. We've got nothing with the hypotenuse. We haven't got those sides, although you could use Pythagoras to get if you really want to use the sine or cosine ratio, use Pythagoras to get that missing side, and that's fine. But we don't really need to do any more work because we've got enough information with using the tan ratio. So we get the 1.7 on 2.2. Throw that in the calculator, gives us a decimal approximation of that. And then take our inverse tan. As we said, taking tan of an angle would give us the ratio. But what if we wanted to find the angle? We need to take the opposite, which we call an inverse tan. Or on your calculator, it's using the shift button or the second function button and then the tan button. But it'll come up with that little -1. That means the inverse tan. And then keep that number the same. Or if you want to put inverse tan of 1.7 on 2.2, that would work there. Using our degrees and minutes button as well, we can go back and find it in degrees and minutes to the nearest minute, making sure we round correctly there. So that's how we can find an angle. And you'll find sometimes we'll have to find angles, sometimes we'll have to find sides, depending on the problem we're given. But hopefully you're getting the hang of what we need to look for when we look at problems with right angled triangle trigonometry.